Hey guys, for this video, I will show you how to prove the mean and variance for Poisson distribution. But before we go into that, wetin be that Poisson distribution? The Poisson distribution na one kind distribution wey dey model random event wey happen within fixed interval. For example, number of car accidents that happen on a road per week. So as Poisson dey model the number of that random event, na exponential go tell us the time wey dey between the random events. So the percentage distribution have its probability mass function, which is PMF, to be probability of x equals x lambda raised to power x exponential minus lambda over x factorial. X equals 0, 1, 2 to infinity. Is 0, 0 otherwise. So we come move to the mean, to proving the mean. So the mean, number one, the formula for mean for now, expectation of x equals probability of x equals x times summation of x, or summation x times probability of x equals x, which is equal to lambda. The mean for a Poisson distribution is lambda. So to do this one, we don't know say our probability of x equals x. Now the mean now summation x probability of x equals x, which is lambda raised to power x exponential minus lambda over x factorial. So we go expand our x factorial. Normal, if we wan expand factorial, e go give you something like this. You know say we no know wetin the x be, maybe na 5 or na 4. Okay, make we talk say 5 factorial, for instance. You know 5 factorial go give you 4, 5 times 4 times 3 times 2 times 1. So you fit use this formula: 5 minus 1 times 5 minus 2 times 5 minus 3 times 5 minus 4. You see this one will give you 4. Sorry, 5 times. This one will give you 5 times 4 times 3 times 2 times 1. So now that's we dey take expand this thing. So x into x minus 1 factorial summation lambda raised to power x exponential minus lambda over x minus 1 factorial. So with that summation, we can't use wetin we dey call power law. This two things no make any difference. Lambda raised to power 1 times lambda raised to power minus 1 will give you lambda raised to power 1 minus 1, which is lambda raised to power 0, which is 1. So we no really make any difference, we just add them. So after adding them, we have lambda. We come factorize this and already we get 1. Factorize them out. Lambda summation lambda x using law of indices. Lambda raised to power x times lambda raised to power minus 1 will give you lambda raised to power x minus 1 times exponential minus lambda over x minus 1. Sorry, I don't forget my put the factorial. So we will say let x minus 1 equals y. So x minus 1 equals y. Lambda raised to power, you know say normal x minus 1 we get here, we don't talk to me equals y over y factorial times exponential minus lambda. So where all this one is 1, as this summation, normal we get for probability, say summation probability of x equals 1. So this na probability of x, summation of all this na 1. So lambda times 1, they mean exponential x and expectation of x equals lambda. So variance, formula for variance na expectation of x squared minus expectation of x all squared, which is lambda 2. So to prove am, since we don't know say our expectation of x is lambda, we solve for our expectation of x squared. So formula for expectation of x squared, expectation of x squared equals expectation of x into x minus 1 plus expectation of x, such that if we open this bracket, that is use x to multiply this bracket, we get x squared, x times minus 1 minus x plus expectation of x, carry expectation inside, expectation of x squared minus expectation of x plus expectation of x. So minus expectation of x plus expectation of x will give you expectation of x squared. This one don't cancel this one. So you don't know expectation of x. It may we estimate for expectation of x into x minus 1, and it will be summation x into x minus 1 probability of x equals x. So that will lead us to our probability of x, which is lambda is power x exponential minus lambda x factorial. So summation x over x minus 1, that is number one, we get summation x over x minus 1 times lambda x exponential minus lambda over x into x minus 1. As I don't explain, say we go expand them x minus 1 because in our variance we dey expand twice, x minus 1 x minus 2 factorial. So x minus 1 cancel x minus x into x minus 1 cancel x into x minus 1. So we have summation lambda is power x exponential minus lambda x minus 2 factorial. So adding the power law wey I talk that time, the two law, we get lambda raised to power minus 2 times lambda raised to power plus 2. So this one no really make any difference now. Lambda raised to power minus, it will become lambda raised to power 2 minus 2, which is lambda raised to power 0, which is 1. So we go return it back to this one. So we come comot this one, carry am to the other side, carry am to the back of summation, go give you summation lambda square lambda square summation lambda x minus 2 exponential minus lambda over x minus 2 factorial. So let x minus 2 equals y. Lambda square summation lambda is power y exponential minus lambda y over y factorial, where all this one now 1. So lambda square times 1 is what is equals to lambda square. So therefore our expectation of x into x minus 1 equals lambda square. Recall the formula for variance now. Expectation of x squared minus expectation of x, where expectation of x squared is expectation of x into x minus 1 plus expectation of x. Show graph, and we know this one to be lambda square. This one na lambda. This one too na lambda, but because of the square, it go turn lambda square. So lambda square minus lambda square na 0. So variance of x equals lambda. So therefore, one property for a Poisson distribution is the mean and variance of a Poisson distribution equals lambda.